Greetings everyone, we're back here on part H of problem 1. Problem 1 has so many parts because we're trying to cover every way that they could throw at you to find the equation of a line. Here the line's graphed. Please ignore the stray little ink marks that have bled through from the previous problems. So here's a problem, and it's got a line graphed, and uh, what that means is we need to either find a slope or a pair of points. And the idea, to make our job as easy as possible, is to try to find a nice pair of points. So let's see. That's not bad. If I connect across there, there's a -2, there's -4. So one point on the graph is -4, -2. And looking for trouble somewhere else. Let's see. 1 doesn't work. 2 is not so nice. 3, 2. If that had not worked out to be nice integers, then I would have to say pick 3.5 or 3.25, pick 0.5 and 0.25, 0.75 somewhere. But as it stands, we found a couple of nice points. So these points, which have integers for both coordinates, have a name. They're called the lattice points. Now, once we've done that, we have a pair of points. If you want, you can compute the slope using the formula. M equals y2 minus y1 over x2 minus x1. I always brought a sheet of graph paper to tests, and you're welcome to bring a blank sheet of graph paper to a test. I graphed them, and besides, I provided the graph here, so why would we not use it? Draw the slope triangle. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the change in the x's is 7. And then the change in the y's is 1, 2, 3, 4. That's the easy way to get the slope. And then pick either point that we want to put into the point slope form. I'm going to use the point slope form here. I'll use the slope intercept form here. I've used point slope on the past several examples. Some people like to do it that way. Some people like to do it with the slope intercept form. On exams, I really don't care which way you do it unless the directions say specifically to use one formula or the other. But if it doesn't say, then you're free to choose. So y equals mx plus b. Well, here we have 4 sevens for this slope. We're trying to find the b in this case, which we know is going to be a little bit more than 0.25, but it's not exactly 0.25. We can't quite read it accurately off this graph. So we're going to have to compute it. And I'm going to use that point because I like the numbers better. The absence of negatives I find rather appealing here. So the x-coordinate is a 3. The y-coordinate is a 2. So in order for this equation to be satisfied for all pairs on the line, if I substitute the 3 in for x and the 2 in for y, this equation has to be true. Therefore, I can find b. You get a 12 sevenths when you multiply 3 times 4 sevenths. I know that I'm going to be having to subtract a 12 sevenths from both sides in the next step, so why not go ahead and write 2 as sevenths? That'll be 14 sevenths. Now I'll subtract the 12 sevenths from both sides. Over here I'll have 14 sevenths minus 12 sevenths. Well, 14 apples minus 12 apples is 2 apples. So that'll be 2 sevenths. You subtract the 14 and the 12 in the numerator of the fraction. You leave the common denominator where it is. So b is that. notice that 2/7 is 0.28, 1/4 is 0.25. So that's why the y-intercept appeared to be pretty close to 1/4, 0.25, but it wasn't exactly that. So with a graph, unless you're sure that it goes exactly through a point, you really have a hard time grabbing the information out of it. But we've got it now. Y equals 4/7 x plus 2/7. And that's the equation of our line. We go next with a fairly important application of linear functions. This is used in accounting. Heck, I remember my father doing this a depreciation of equipment in his construction business, and basically one of two methods that the IRS approves of for depreciation of equipment is straight line depreciation. It's the easiest one of the two to use. So basically, if you buy a computer over time, the value goes down. That's called depreciation. Your car does the exact same thing. You drive it off the dealer's lot. 2 weeks later, it's worth $2,000 less than you paid for it if it was a new car. They're giving us some information here. Let's see. 2 years after the computer was purchased, it's worth $2,000. 3 years later, it's worth $400. So that's going to give us enough information to come up with two XY pairs. So assume the relationship between the value and time is linear function. That means that we can assume that the thing is a line. So we can do everything that we've learned in this section. Express the value as a function of age. Now notice that you have as a function of as your keywords again. That means you look back here and you find the output. You look over here and you find the input. Okay, so value of the computer is going to be the output. We may as well call that the Y. And input is the X. And notice input is the age, it's not the year. So that does not equal the year. Okay, so that means that we want to get, since we want a line, we want a pair of points, a point and a slope. Yes, we want our two pieces of information, and we noted that up here in this sentence we had enough information to get out 2 points. So let's do that down here. 2 years after the computer was purchased, so 2 years after, that means the age equals 2 years. So that's going to give us a point where age is the X, 2, and then it was worth $2,000 because the Y is the value of the computer. So we'll remember that this is in years, this is in dollars. The second sentence, or the second, second sentence here, 3 years later. Notice the word 3 years later. So that would mean that the age equals 5 years. 2 years plus 3 more is 5 years. And we're only worth $400 then. Very few things depreciate as quickly as computer equipment. So now we have 2 points. Now we can take these 2 points, we can do exactly what we've been doing for all of this section. We can compute the equation of this line. So we'll start off with a slope. M equals y2 minus y1 over x2 minus x1. So let's see, 2,000 minus 400. So I'm subtracting that y minus that y. That means I got to subtract that x minus that x. So 2 minus 5. So you'll have 1600 over negative 3. So negative 1600 divided by 3. I guess for my boss, they probably would like to see this maybe in dollars and cents. So 1600 divided by 3. So it's losing 533.33 repeating dollars per year. I wrote that down the way you would write it in a science class. The way that you read it is minus 533.33 repeating dollars per year. And in fact, whenever you see the word per in algebra, that's a fraction bar. So we got the slope. And we have to go to another piece of paper so that we don't squish this stuff too badly. I want to finish up getting the equation of the line here. We've got the slope. So y minus y1 equals x minus x1, y minus x minus, go ahead and drop in the slope, minus $533.33. And then we need to pick a point. 6 of one, half a dozen of the other. Why don't we just put, I'll use the second point here. So the y is a 400, the x is a 5. So distributing through the parenthesis, negative 533.33 repeating x minus. Since I left this here in the display of my calculator, I can simply multiply, provided I don't clear it. So second insert, negative, there we go, got it back. I can simply multiply what's in the display of the calculator by the 5. I've learned over bitter experience not to round off unless I have to. So I have negative 26666.66 repeating. So now notice I'm doing a negative times a negative, so that will be positive 2666.66 repeating. And that's y minus 400. Then y equals negative 533.33 repeating x plus, I'm going to be adding a 400 to both sides, so I come to the calculator and I say plus 400. So negative 2266 with 6 is repeating, except it's positive. So that's probably not right. Nope, that won't be right. If I add, I'll be up above 3,000, so slight mistake there. So if I just add 800, I'll be where I should have been, and I'm making it even worse. 2666.6 plus 400. That's better. I could have actually done that in my head faster. 3066.66 repeating. So I usually, if it's not any more effort than this, I just leave the things with infinite precision, and then when it gets down to getting a final answer, I know that I don't have I've not built in any internal round-off error. So that takes care of part A. We move on to part B. Use this to estimate the value of a computer in the year 2006. So we have to go back to the original statement of the problem. The computer was bought in 2003. So in 2006, the computer is now 3 years old. So x equals 3. So then we simply put into our equation, we substitute x equals 3. So, and here we can go ahead and round off because they said estimate 533.33 repeating times 3 plus 3066. If I'm going to go to the nearest cent, that'll round up to a 7 there. And let's put that in and see what we get. Negative 533.33 times 3 plus 3066.67. I really advise typing the entire expression into the calculator like this. You can do second left arrow, and that'll jump you to the beginning of the line. You can arrow back and forth and check. As long as you've entered it in using correct order of operations, the calculator knows how to interpret the order of operations correctly. It'll get the right answer for you. So it's 146668. So 1466.68 $. Remember, when you're giving answers to the real world, units are vitally important. Now, up here that we're supposed to estimate the value. The word value we saw on the last page was associated with the variable y. So we were supposed to find y. Down here they say use the equation to estimate the age. So we're supposed to estimate the age. That means we're supposed to find x. When the computer is worth $1,000. So here they did not give us an x value to plug in. Notice the units on that. Those are dollars. Dollars are things that go with y's. So we'll be using the exact same equation. Y equals negative 533.33 times x plus 3066 and change. But we're going to put the 1,000 in for y. So 1,000 equals negative 533.33 times x plus 3066.67. You can use your units to decide what variable the numbers go in. Units are your friend. Then, once you get things in the correct place, simply solve for the other variable. And we, in fact, are supposed to be solving for x, so this is set up correctly. We just go to town. Subtract 3066.67 from both sides. Well, you subtract that from 1,000. That's the same thing as doing 3066 minus 1,000, then changing the sign. So you get negative 2066.67 is negative 533.33x. Then simply divide divide both sides by negative 533x. So negative 2066.67 divided by negative 533.33 and see what you get. Now we're dividing negative by negative, so that's going to be positive. I'll simply drop off the negatives. 2066.67 divided by 533.33. You get 3.875. So 3.875 years. But they said to the nearest month, so they don't want decimal years, they want years and months. So how many months is 0.875 of a year? So once again, jumping to another sheet of paper to have some room to work. X equals 3.875 years. Well, that's going to be 3, years is YR. That's going to be 3 years plus 0.875 of a year. I'm going to go ahead and convert units the way you convert them in your science class because that'll be good practice for you. So we're going to do what they call dimensional analysis here. I'm going to be changing years to months. The usually accepted agreed abbreviation for months is MO. So 1 year is 12 months. The years cancel, and then you're being prompted to do 0.875 times 12. So what I could do here to get the 0.875 is subtract the 3, then multiply by the 12, and you get 10.5 months. So X equals 3 year, 10.5 months. And you could round that up to 11 months or leave it as 10.5 months depending on what your boss is expecting. Now, I want to make one more comment here, and this is worth a sheet of paper unto itself. A few pages back, we got the slope of this line as minus so many dollars per year. So I'm going to write that here again. You can use your units to check your answers for a slope. If you have 533.33 repeating, the numbers are really not important here. Remember that for this problem, if we go up here and look, we see that the output is the value. The units on the value are dollars. So if your slope is correctly stated, you're going to have the Y units on top, and the X was in years. It wasn't the year, it was the age, but the age was measured in years. You're going to have the X units on the bottom. So a slope in a real world problem looks like, it's going to look like a number, and then it's going to be Y unit per X unit. That's how you will actually say it. So for instance, in some problems, the slope is a speed. You might have 37 miles per hour. Sometimes you have things like 32 miles per gallon. So slopes always have a unit. Since a slope is a change in y or a change in x, a slope is going to have the word per in it, in its units. And that's a good way to check yourself that you've got it set up correctly. If you see your y units per your x units, then you're probably on the right track.